All right, it's time to wrap up our unit on the basics, the essentials of geometry. We're going to finish up talking about angle pairs. And as you can see from the little comic there, we're going to talk about complementary angles. Well, not that kind of complementary, spelled a different way. But we'll be discussing different groups of angles, such as complementary, supplementary, vertical angles, a linear pair, and find out the relationships that these different angles have and how we can use that to help us solve problems. So follow along and take notes, pause and rewind as you need to. The first section we'll take a look at here is just how to interpret a diagram. Figure out what we can tell from a diagram, what needs to be told us before we can just assume. You never want to assume anything. So take a look here. There's some things we can conclude. So let's take a look at this diagram here. We can assume that everything is coplanar. Since it's all on the page, it's all in the same plane. There's no dotted lines to show that anything's coming out in a different plane. We can assume that A, B, and C are collinear, and B is between A and C since they're all on the same line. We can assume that AC, ray BD, and BE intersect here at point B. These are all labeled there. We can assume that DBE and angle EBC are adjacent angles. Adjacent angles I mentioned in a previous lesson are ones that share the same ray. Okay, and we can say that ABC is a straight angle since it forms a straight line. We can say that point E is somewhere in the interior of angle DBC. Okay, interior just means it's inside of, here's where we're measuring that angle. Okay, that's what we can say. What we can't say is that AB is congruent to segment BC. Okay, it looks like it might be, but we can't conclude that. The only way that we could say that is if the angle markings, the tick marks, show that. Okay, unless it's there, we can't say that it is. We can't say that angle DBE is congruent to angle EBC, even though it appears that it probably is. The only way that we could show that is if these arc markings were there that show that those are congruent. And even though it looks like angle ABD is a right angle, we can't say for certain unless this marking is here. That box in the corner indicates right angle. So never assume anything in diagrams unless the information is given to you. Okay, so let's talk about the different kinds of angles. As I mentioned earlier, we're going to talk about complementary angles. That comic in the beginning, complementary with an I, means you're saying something nice about someone. But here, complementary refers to something different. So angle E and B are complementary angles. This angle that's 30 degrees and this one's at 60 degrees are complementary. But these two angles are not complementary, E and B. Neither are angle H and G. So can you figure out what makes a set of angles complementary? So brainstorm for a second and we'll talk about that in just a moment. So complementary angles are two angles, okay, with a sum of 90 degrees. Okay, so hopefully you could see that from the different examples and non-examples. These two form a right angle. 30 and 60 add up to 90. These two do not add up to 90. These two don't either. Complementary angles don't necessarily need to be adjacent either. Notice these are separated. Okay. Next we have the supplementary angles. Why don't you take a look at the angles EB, 120 and 60, EB and HG. See if you can come up with a definition for supplementary angles. Pause it to give yourself time to think and start it when you are ready. So supplementary angles, similar to complementary angles, these are two angles with a sum of 180 degrees. Okay, just like complementary, they don't necessarily need to be adjacent. You know, it's two angles that combine to give us 180 degrees. Okay, so complementary, supplementary, kind of similar terms. The way that I remember them, which one adds up to 90 and which one adds up to 180? I think, well, complementary, C, comes before supplementary, S, and C comes before S. 90 is smaller than 180. I don't know if you'll remember that or if that makes sense to you at all, but it makes sense in my mind, so do with it what you want. Anyway, Moving along, let's work with complements and supplements. It says in the figure, name a pair of complementary angles, a pair of supplementary angles, and a pair of adjacent angles. Why don't you pause the video and come up with those on your own. When you're ready, start it up again. Okay, so the ones I came up with, the complementary, the ones that add up to 90, I had angle BAC, which is 32 degrees, angle RST, which is 58 degrees. Those two add up to 90 degrees. Supplementary, CAD and RST. Those combine to give us 180 degrees. And the adjacent angles, BAC and CAD, they don't necessarily have to add up to a specific sum, but they just share a common ray and vertex. Okay? So let's move on. Another way to work with complements and supplements. Let's say that we know angle 1 is a complement of 2. If 1 is 68 degrees, what would angle 2 have to be, or measure of angle 2 have to be? And in the same way, B, given 3 is a supplement of 4, measure of angle 4 is 56 degrees, find out what the measure of angle 3 would have to be. You calculate that on your own and see if you get the same thing that I get. So I found the measure of angle 2, since it's a complement, be 22 degrees. 22 plus 68 adds up 90 degrees. And then measure of angle 3, I got 124, because 124 plus 56 equals 180 degrees, since it's supplementary. Okay? So we can do the same thing here when we have an expression. So in this case, the ball return net forms a pair of supplementary angles. BCE is supplementary to ECD, which means they equal 180 degrees. So the expression 4x plus 8 and the expression x plus 2 would equal 180 degrees. You can set up that equation and solve it and see what you get for x, and then find the measure of each angle. Okay, so as you can see, I set up the equation 4x plus 8 plus the expression x plus 2 equals 180. I simplified, 5x plus 10 equals 180, subtracted 10 from both sides, and divided by 5 to get x equal to 34. Plug 34 back into each expression, so 4 times 34 is 120, plus 4 times 4 is 16, so 136, plus 8 is 144. Then angle ECD is x plus 2, so 34 plus 2 is 36 degrees. The two combined to equal 180. Okay, so you can't get too far away from your algebra skills. Always keep creeping up, no matter where we go. Next, let's take a look at what a linear pair is. These two are a linear pair, an R and F. These two are not a linear pair. Okay, so what's in common? What makes them different? How would you define a linear pair? Take a moment to pause it and think about that. So linear pair, hopefully you noticed, linear pair, these are supplementary, and these are supplementary. So a linear pair is a set of supplementary angles, but what makes them unique is that these supplementary angles that are also adjacent. Okay, so we can define these as adjacent supplementary angles. Okay, so adjacent supplements. Okay, so equal 180. But they share a common ray vertex. Vertical angles. AC are vertical angles, F and D. B and E are not vertical, neither are H and G. So brainstorm, what is a vertical angle? So a vertical angle, okay, angles that share a common vertex. Okay. So notice these have a common vertex, but these also have a common vertex. So what makes them unique is that they also have opposite rays. Okay, they both have opposite rays as well. Okay, oops, and that's what makes them unique, is they have two sets of opposite rays. Okay, so not only do they share that common vertex, but they have two sets of opposite rays in their angles. Okay, some people like to think of them as angles that are opposite of each other. Okay, but we want to make sure that they have the opposite rays. They're not just across from each other. Okay, let's move on. And let's identify angle pairs. So see if you can find any linear pairs or vertical angles in this figure. Pause it and take the time to look for those, and when you're ready, restart. Okay, so these are the ones I found. The linear pair I found were angle 4 and 5. These are supplementary angles that are adjacent. And I see another one now that I didn't mark that one up. I see angle 1 and angle 4 that I should have also included in there as a linear pair, because those are supplementary and they're also adjacent. None of the other ones we would say form a linear pair. 3 and 5 are adjacent, but they aren't supplementary. Okay, vertical angles, angle 1 and angle 5 I included. They have a common vertex, common endpoint, and two sets of opposite rays. Okay, we wouldn't say 4 and 2. They have one set of opposite rays and a common vertex, but this ray that forms the second part of angle 2 and angle 4 are not opposite. Okay. Now, finding angle measurements within a linear pair, if we know these two angles form a linear pair, if this angle is 5x and this one's x, how would we find the measure of each angle? Well, what do we know about a linear pair is that the sum of the two angles equals 180. They are supplements. Okay, so I can set up an equation combining the sum of the two angles. 5x and x is 6x. That equals 180 divided by 6. X is 30. So if x is 30, this one is 30 degrees. This one is 5 times more, 150 degrees. Okay, so that is how we apply what we know about the angle pairs. There are many different angle pairs that we learned today. But the first thing we learned was don't take anything for granted in a diagram. It must be included for us to say that it is true. We learned about complementary angles, angles that add up to 90, supplementary angles that add up to 180 degrees. We also took a look at a linear pair, which are adjacent supplementary angles. We have vertical angles, which share a common vertex and have opposite rays, two sets of opposite rays. We'll take a look at another quality that vertical angles have as we continue through our journey in geometry, but we'll get that a little bit later. And those are the types of angle pairs that we worked with, and we can create equations to help us solve them. You have some practice problems where you're going to be applying those concepts. If you have questions, be sure to bring those up when I see you again. All right, we will see you in class.